Hello, this is Mrs. Huntley. This is Module 2, Lessons 2 and 3. For Lesson 2, it's the definition of a translation and 3 basic properties. You should be on page 10 of your student workbook. If you were in class today, I'm going to just repeat what we did today in class. So if you were here, you can go ahead and fast forward, I would say about 10 minutes or so. And if you were not present at school today, you're going to want to watch this first section. So our essential question, what are the 3 basic properties of translations? And we identified in school today that in elementary school you might have called them slides. And throughout this unit we're going to be looking at 3 basic rigid motions, translations, which you might have learned about as slides in elementary school, reflections, which you might have learned about as flips, and rotations, which you might have called turns back in the day. So this is a familiar picture. This is revisiting our open discussion question, which was in lesson 1. What is the simplest transformation that would map one of the following figures onto the other? Remember, we copied this one onto our transparency and we slid it over and up until the shaded parts matched each other or until the curved part mapped to each other. We're going to introduce something called a vector right now. And what vectors do is they show us a distance and a direction in the coordinate plane. So if I draw a vector between corresponding points on my 2, they look like whistles to me. So if I connect my 2 whistles by a vector, I would want corresponding points. So what are corresponding points? It's the points that are the same when the 2 figures are on top of each other. So when I move this guy on top of this guy, my 2 corners here correspond with these 2 corners here. So I can draw a vector between one of those 2 corners. And I'm going to actually make my vector be red. So I'm going to connect this bottom corner to this bottom corner, and that shows me the distance that was moved and the direction that was moved. So just to reiterate, what is a vector? A vector is a segment, actually it's a ray because it has that arrow on one end, that in the plane that shows direction and length. Now I could label my ray. I don't have to, but I could. Where's my pen? There it is. So if I said this is A and this is B, the way I would talk about that ray, what I'd say was ray AB, and that's showing me that I start at A and I end at B. Now if I was going in the opposite direction, if I was going from the figure that was up here to the figure that was down there, I would say that it's ray BA, with an arrow going that way. Okay? So that's just how I would label it. And yes, it could go in either direction. It depends on where the arrow is. So now we're going to do a couple of examples. And I realize that there are no directions on these examples. So I'm going to give you some directions. You can write them down or not. And then I'm going to switch the overhead and I'm going to demonstrate how to do this. So the directions would be copy the point P and the vector onto your transparency. You're just going to copy the solid line, not the dotted lines. Slide the beginning of the vector A up to the end of vector B, and then draw in point P. And if you're like, wait, what? It's okay, I'm going to demonstrate it, but I just wanted to give you the directions first. And I'm actually going to give you the directions for the next one as well. So here, I'm going to copy not only the points, but line L onto my, and the vector, again, just the solid part, onto the transparency, and then I'm going to slide the beginning of the vector, which is here, up to the end of the vector, which is here, and then draw in the points. And then we'll come back and we'll talk about some of the observations that we made about the basic properties of translations. So let me turn on the overhead and do these demonstrations for you. There we go. Make sure you can see what I'm doing. Okay, so I'm going to grab my transparency and my pen. So on my transparency, I'm going to copy point P right there and just the solid part of my vector. This is A and this is B. I'm going to slide up the vector until A maps onto where B is. And I know that's going to be my new point for point P. But being that I can't write through my transparency, I'm going to grab my pencil and kind of slide it under and make a point where it should be. Okay. And this is P prime. Because again, after we move it, we've got to add that prime sign so I know where it started, where it moved to. And that's how I translate a point. Now please notice, it was a point before I moved it. It's a point after I moved it. Don't be confused by that. That's just hinting as to some notes that we're going to be taking later. So if it's a point before you move it, it's going to be a point after you move it. Looking at example 3, clean off your transparency and grab your pen. And I'm going to put my transparency over. And this time I'm going to copy both points, the line L, and my vector. Again, just the solid point part of the vector. This one doesn't have points on it, so I'm accentuating where the beginning is and where the end is, okay? I'm going to slide up. Again, I'm going to sneak my pencil in underneath. There's one point, and there's another point, and I'm just going to make a dot where the top of the line is. And then I'm going to take my handy dandy straight edge that hangs around my neck. Put that line in, put my points in. Now this is L, so this will be L prime. Okay, that's how you translate. Now some things I want to point out to you. If I grab a ruler and I say the distance between these 2 points is 1 centimeter, after they're translated, it's also going to be 1 centimeter. Okay? The length of this line segment is 5 centimeters. After I translate it, I can't get my ruler in there. After I translate it, it's going to be 5 centimeters. So my lengths of my segments are preserved. The distance between points are preserved. This is called a rigid transformation because all of that is preserved. Okay. Going back to our book, what are some observations? Well, first of all, let's look at this picture down here really quick. In mine, you can see that the transformed picture is in red. And I want to point out to you that here we've got a P, here we've got a P prime, Q, Q prime, O, O prime. So after they're moved, we label them with that prime, that apostrophe that tells us that something's happened, something has moved. So what are we noticing? A point translates to a point, a segment to a segment, an angle to an angle, and a ray to a ray. Whatever it was before you moved it, it's going to be the same thing after. Segment length is preserved and angle measurements are preserved, meaning whatever the angle measured before you moved it, it's going to be the same thing after you move it. I hope that makes sense because again, a rigid transformation, we are not changing the picture, we're just moving where it is. And we can translate a point, a line, a figure, a drawing, whatever. Okay. This next exercise I actually want to do in class. So if you're not planning on coming to school tomorrow, you will have to do this on your own. I will explain it. You're not going to draw all of these figures going in all different directions. You're going to pick out one of them. Draw a vector and move it. If you're in class tomorrow, we'll do this together tomorrow. Example 5, what the notation to represent the image is, okay, so the image is after you've transformed it. So the pre-image is going to be labeled with an A or whatever. After it is transformed, we would add the prime sign, which is like an apostrophe next to whatever it was called to begin with. And we say that it's A prime. As we get into more involved transformations, there might be a time when we actually do a double transformation. And then if we have moved it twice, say we move it from our pre-image to our image, and then we're moving it from our image to somewhere else, we would add another apostrophe and we would call it a double prime. But that's coming. I just wanted to give you an idea that there is more challenging information coming. All right, on the next page, it says the diagram below shows the figures and their images under a translation along vector HI. Here's our vector HI. So this is our original because it doesn't have any prime signs on it, and it's moved along this vector down here. Oops, I have some answers on there, didn't realize. Okay, because this is not my first time recording this video. Yay! Anyway, what happens is I've taken it from up here, I've translated along this vector, and then my images are down here. Now we've learned that things coincide. We call them with a prime afterward. So if this is C prime I know this is the segment that was translated. This would be the point that corresponds to it. So this point is going to be called C. Similarly, if this one over here, whoops, where's my skip? Over here is F prime, then I know this one's going to be F. If you're comfortable, go ahead and pause the video and see if you can label the rest of the missing parts of this picture. So we've got some angle names and some measurements. So go ahead and see if you can do that. If you're not comfortable, you can just follow along and I'm going to fill it in. That's where there's two C primes that should be. I guess this dot didn't get to me. Okay. Okay, so hopefully that makes sense to you. And we're actually going to go right into lesson 3 right now. The rest of this independent practice we're going to do in class tomorrow, as well as the summary. So for lesson 3, I know we have, when we've been pressed for time, we just skipped lesson 3, but I was actually looking at it, and lesson 3 has some great information in it, so I didn't want to skip it. So we're just going to combine it kind of with lesson 2. So your essential question for lesson 3, what are the special properties when translating lines? So this is going to be all about just translating lines, not translating anything else. So this first warm-up, it says work independently. Draw a line passing through point P that is parallel to line L. Draw a second line. So let's draw our first line first. And we want arrows on both sides because it's a line. And I'm going to make it red. And I'm going to make it a little bit fat. Okay. So going through P. And I made it a little bit fat for a reason. You'll see why in a minute. I want to make sure that it's going exactly through that point, okay? And it's going to be parallel to this line. Now it's saying draw a second line, and this one I'm going to do thinner. And I'm going to do it in, we'll go green, okay? So I need to go through point P, and I need to make sure it's parallel. So I could go through point P like this, but that's not going to be a parallel line. So that's not going to work. I need to make sure that my line is going to stay parallel. So I know it's going to start over here. Whoops, that's not what I want. My cursor is not working. There we go. So, okay, well, that's going through point P, but it's on the same line as my original line. So what this is telling me is there's one and only one point. If there's a point that's not on the line, there's one and only one line that can pass through that point and also be parallel to the line at the same time. You can draw it multiple times, but it's still going to be the same line. There's going to be something called collinear or coinciding. So we're going to get to that vocab in just a minute. So what I'm going to do is I'm going to switch again to the overhead, and I'm going to demonstrate rather quickly how to do the translations for 2, 3, and 4, and then we're going to come back and pick up the notes for it. So let's go ahead and do that. Okay, so translating lines, we already did that one. Here we've got translate line L along the vector AB, and what do you notice about L and its image L prime? So AB, our vector, is on the line. So I'm going to grab a transparency. I'm going to copy the line first. And then I'm going to grab a different color. And I'm going to copy the vector. So I'm going to move A onto B. I'm going to slide over. And what do I notice? My new line is going to be on the same line as my old line. So the image and the pre-image are going to share the same line. We call that coinciding. They're sharing the same space. Okay. Example 3. Line L is parallel to vector AB. translate line L along vector AB. What do you notice? So I'm going to copy line L, and I'm going to copy AB. And again, A is going to go on to B. So I'm going to translate it over. And look, my L and my L prime, again, are going to share the same space. They're going to be coinciding. Let's pop back and grab the notes. So, whoops. If the vector is on the line that's being translated, the translation of the line, the image, will coincide with the original, the pre-image. That means every point that's on the image is also on the pre-image and vice versa. When I say vice versa, it means and the other way around. So if it's on the image, it's going to be on the pre-image, and if it's on the pre-image, it's going to be on the image. So let me highlight a couple of things that we're going to talk about here. We've already got vector coincide is going to be one of our vocab words that we're going to fill in a little bit. Similarly, if the vector is parallel to the line that's being translated, so the vector is parallel to the pre-image, the translation of the line, the image, will also coincide with the original. Again, that means every point that's on our original line is going to be on our translated line. They share the same space. Let's do the next example. Okay. So example 4. Translate line L along vector AB. What do you notice? So this line, I'm going to translate along this vector. And when I do, and if I had drawn this straight, you would see that this is going to be a parallel line. So if your vector is perpendicular to the line that you are translating, you're going to get a set of parallel lines. Perpendicular means it meets the pre-image at a 90-degree angle. So that's a 90-degree angle, and I can actually draw in here the line that we translated. Okay? So here, this is just it's reiterating what we know. The line L has been translated, so this L prime is from here. This is perpendicular. What do we know about those two lines? And they are parallel. So at this point, I'm going to invite you to pause the video and see if you can perform this translation. So you're going to translate both of these lines along this vector. If you are not comfortable doing it on your own, I'm going to go ahead and demonstrate it, but I would like you to start branching out and doing this stuff on your own too. So, okay, here we go, and there's our image. So, neatly as I can, line 1 and line 2. And here's my vector. And I'm going to slide along that vector. And I see line 1 and line 2. First of all, they're going across the middle of the book, so I know that it's going to be hard for me to draw them in underneath. But they were parallel before I moved them, and look, they're parallel after I move them. And they're actually even parallel to the originals. So the notes I want you to have, if the pre-image is parallel, then the image is going to be parallel. And that is the end of lesson 3. So now we have to go back and pick up some vocabulary. I know I'm running tight on time, but hopefully you didn't have to watch the first part of it if you were actually in class today. So I'm going to have you go back to page 3, I think is where we're starting. Yes, page 3, coincide. So when lines coincide, they're on top of each other. They correspond in position. So the example I tried to draw for you is two lines that are coinciding, and you can barely see the one that's underneath it. Hang on, let me move this one. You can make this one fatter maybe. Make that one fatter, and then I'll move it back on top. And you can see, whoa, that's not what I wanted to move. Come on now. When they coincide, they share the same space. One's on top of the other. When something's collinear, that means they're lying on the same line. So these 3 points, we call them collinear because if I do draw a line, oh my goodness. If I do draw a line, they're going to be on the same line. We'd say that they're collinear, but it doesn't mean I have to necessarily draw the line. It just means they're sharing that same line. Does that make sense, I hope? Okay, next page, vocabulary. I think we did image and in the plane for lesson 1. If you didn't get it, go ahead and pause the video and grab them. Intersect. 2 or more things passing through each other. So the example I had here are 2 lines, and I highlighted where they intersect. So that's where they cross. Line and mapping we did for in lesson 1. If you didn't get it, by all means, go ahead and pause the video and write them down. Parallel. 2 or more lines that never ever cross or intersect. And the example I have are 2 parallel lines. Perpendicular. Lines that intersect at a 90-degree angle. And then I drew in my intersection, and I put that in here so that you know that is a 90-degree angle. Prime, if the point is labeled A, after it's transformed, we call it A prime, and we say A prime. I didn't know what other example to give you, so if you come up with one, let me know. Vector, a vector is a segment or array in the plane with a direction and length. So if you label it AB, you've got an arrow on one end telling you what direction to go. This would be the beginning, that would be the end. Rigid motion we did in lesson 1. Segment we did in lesson 1. Transformation. Translation is a slide. The size, shape, and orientation are preserved. So I just gave you my original example for image and pre-image because that shows a transformation. Or I'm sorry, shows a translation. And let me see, did I miss one? Nope, that's it for the vocab today. So I was pretty close on making it under 20 minutes, and hopefully, like I said, if you were in class today, you were able to zip through this a lot quicker. So have a great rest of your night. Talk to you later. Bye.